welcome to Minecraft Math Computers episode I37 binary addition. Today we're going to talk about doing binary addition, which is actually very simple because if you remember, binary is just ones and zeros, which makes it quite easy to do math. Surely you can add ones and zeros. Let's take a look at what we get. For this purpose, I have built a new device all the way back here, which carries with us quite a bit of binary displays. Now these are the same binary displays that I built before that just show a 1 or a 0. I can come down here and click a button and change a 0 to a 1 and toggle it back and forth. That's all this device does. If I put 0 on everything, this is what we have. So we're going to do addition just like we're used to, but let's talk first about doing base 10 addition.
So for base 10, we use the number of numerals in the base, which is 0 through 9, which is 10 numerals. A numeral is a symbol used to represent a number of items in the real world. That is what a number is. We use symbols to represent these in symbolic math. In base 10, a number uses a series of these symbols, starting with the 0, which is the first symbol. We count upwards until 9 in base 10. Any number actually consists of multiple zeros, going as far as you want to infinity, but not beyond. The first one we pick then is 10 to the 0 power, which is 1. We put a number there, and we take 1 times the power, and that we call the ones. The next one over is 10 to the first. That is tens, so that is the number of tens. And last is next in this number is 10 squared, or 10 to the 2, which is 100. But this number is actually a compound. If we look at it, it's actually saying there are 2 100s, 3 10s, and 6 1s. We can advance forward with 10 to the 4, 10 to the 5, 10 to the 6, 10 to the 7. Each of these is another exponent of the base. To add two base 10 numbers, we simply line them up with the 1s aligned with the 10s and the 100s, and we add. If the resulting number, which can only be a number less than 20, exceeds 10, that means we have 1 10 in the answer. We're used to putting this above, we call carrying it. It carries over to the next column. So when we add the ones together, if we get a number like 12, we end up putting the 1 in the tens column and adding it. And that is how base 10 numbers are added, from right to left, carrying whatever value is moved forward.
Okay, so just like in base 10, these are our binary digits, starting the one with the least significance to the most significance, moving this way. So this is 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4th, and so on, all the way up to 2 to the 7th, 128. So as you remember with binary, you have a 128, 64, 32, 16, 8, 4, 2, and 1, and this indicates whether you either have that number or you don't if you're converting to base 10. Binary addition is actually quite simple. So let's take our first number that we could put. We're going to put a 0, 0 up here, and of course 0 plus 0 in any base is still 0. So that is the number. If I instead add a 1 on the top up here, you can see right there. So now I've got 1 and 0. That means if I add 1 plus 0, then down here on the bottom, I would get a 1, just like that. Let me clear those, and of course, if we're doing it the other way around, and put my 1 here, that's the middle row here, and I say 0 plus 1, just like 1 plus 0 is still a 1. 0, 1, 1. So those are simple. 0 plus 0, 0. 0 plus 1, 1. 1 plus 0 is still 1. Now what happens though if we do this? If we put a 1 up here on the top, which would normally be a 1 added a 0, we put a 1 here. Now what happens? 1 plus 1 in base 10, of course, is 2. But the 2 is represented over here in this column in binary. So actually when you add 1 plus 1, just like regular base 10 that we did earlier, you carry the next digit over to the next column. So the 1 actually then moves over to this column, meaning that this becomes our answer. So we would have a 1 for a carry, plus 0 is 1. So that is 1 plus 1 in binary. If you think about it, that's really all you have to do. Just like in base 10, if you know how to add 2 of the numerals, 0 through 9, then you know you just do that repeatedly from the right to the left. So the same thing would occur in this way. So for this reason, I have over here created a carry location. If I turn this one on, this shows that we are carrying a bit. Now, just like the base 10, we typically have learned to write it over the next column, so we learn to add it back in. But in binary, it's very often just to have a single place. We could do the same thing, but we don't have to. I'm just going to demonstrate we need one place. So in this case, if our problem were 0, 0, 0 plus 0, we have no carry. So we end up with a 0 over here. Same thing here. I'll put a 1 there and a 1 there to make it a little more interesting. Now I can indicate, well, 1 plus 1 actually has a carry of the 1 to the next column. So I'll turn on the carry, and then I'll do the addition, and 1 plus 1 makes this column a 0 with a carry. So in that case, we're going to take all of these, leave that as a 0, sorry, my mistake, leave that as a 0, and then we go to the next column. We say, is the carry on? Yes, the carry is on, so we have 1 plus 0 is still a 1. So 1 plus 1, binary equals 1, 0, which is 2, of course, in base 10. Let's clear the board and go on to the next number. We would do the same thing in this column. Let's suppose that we had a 1 here and a 1 here. You can see that's going to be there. And we add those together. Well, then we would still end up with a 0 here in this column. And the 1 would carry into the 1 flag over here, the carry flag. And then these would be reset, and that would be left 0. And we would add the 1 over here. We say 1, the carry, plus 0 is 1. That would indicate over here. So you can see in this case, 2 plus 2 in base 10 is 4. And that's the same thing we have in binary. So binary is very easy. We just keep carrying a 1 whenever we need to. What happens though, however, let me back this up. So we have 0. Now suppose instead we've already added 1 plus 1. We got 0, we turn the carry on, and now the next 2 bits are 1 plus 1. What do? We get 1 in the carry plus 1. So we have 1 plus 1 is 0, put the carry on. And then we also add this. So 0 plus 1 is a 1. That would make this column a 1. So 3 1s make a 1 with the carry turned on, and now we're ready. Now we would say we have a 1 in the carry plus 0 is set here. 1, 1. So in that case, we had the carry turned on, plus 2, which is 5. So we had 1, 1, 1. 3 1s make a 1 with a carry. We leave the carry turned on, and then we would be done. So in this case, the last step we have to do is we no longer have a carry. We've turned it off. There we go. So that's all you have to do for binary numbers. You had 0, 0, 0, 1, 1, 0, and 1, 1. We know those, and then we add the third one in for when the carry flag is turned on. So let's take a look at and do a few of these problems and see what we would come up with. Clear the board here, set a 0, and clear the carry. All right, we're going to make this pretty simple. Get the carry back off. I guess I just turned it on. So here's the board. We're just going to add a binary number up here. Let's make it this. And we'll put the same number, or a different number, I should say, down here. And we're ready to add. So we start on the right hand, just like base 10, and we say 0 plus 1 is a 1 with no carry. Then we go here, and we say 1 plus 1 is a 0 with a carry. So I just turned the carry flag on. Now with the carry flag turned on, I say, I've got another 1, so I add 1 to 1. That makes it a 0 with the carry. So we leave the carry flag on, and then we say 0 plus 0 is 0. So nothing changes. Once again, we have the carry flag plus that becomes 0 with a carry. So we leave the carry flag on. And then we say 0 plus 0 is 0, and we move on. Now we start here. Carry flag is on. We add that to 0 here. Gives us a 1. And then we add that to a 1, which means this column stays 0. And the carry flag stays on. This stays a 0 as well. And now over here, we also have the carry flag on. So the carry flag plus 1 makes it a 0 with the carry flag on. We leave the carry flag on. 0 plus 1 is 1. So in the fifth one over, we actually have a 1. Carry flag is on. So we add 1 to 0 to this one right here. We get a 1. We add that to a 0, we get a 1. So the 6th one over. We end up with a 1. And no carry in this case. We've got to turn the carry off. And then the last one we have here is 1 plus 0 is 1. So in this 6th bit, we end up with a 1. So that is all we need to do. Let's look at this very closely, logically. So here's a table that shows 3 different inputs. I have A and B. A would correspond to this row, the top one. B would correspond to this row, the middle one. And then our output is going to be this one, we'll call that C. And of course we have the carry flag too. So I have an input from A, an input from B, and an input from the carry flag. So I have 3 input bits, and I have 2 output bits. One is the result of adding, and the second is the carry bit. So I'm going to separately create a table that shows this. This is the truth table for this. And this is what our truth table looks like. Okay, so this is the truth table for this. We have, in the left-hand column, we have A, that is the input of the top row here on our binary board in Minecraft. And then we have B, which is the second number, the middle row in Minecraft. And then we have the carry in, and that is this light over here on the left. So it acts both as the carry in and the carry out. So we have 3 inputs. We have a bit from the top row, a bit from the middle row, and then we have the on-off state of the carry flag over here on the left. So what we do is we build this table where we have 1 input for every one of those, starting with all of them set to 0. And then on the right-hand side, we have the output state, that is the bit out that we would have by adding both A and B together. And then we also have the carry out, which we're going to indicate on the same carry light over here on the left. So for every possibility that we have with those 3 bits, okay, which is going to be 8, because it is 2 to the 3rd, we have 3 bits and 2 possibilities, 2 to the 3rd, we list in this table. So this is simply saying you would look at the A, B, and C flags, or the C flag, the A, the B inputs from the bits over here on the board, and decide what you want to do. If they're all off, then you get an output of 0, and the carry is off as well. If, for instance, A is on here in the second row, and B is off, and the carry is off, well, then you get a 1 in the output, and the carry flag is off. And that's how you use this table. It's just simply the truth table for all the various possible inputs for our 3 bits, A, B, and carry in. To use this table, all we do is we align our carry here on this column, it's the 3rd column, and our A and B from the board, and we just look up what our output is, and we set the board for each bit. So we start on the right-hand side, and we move to the left and do 1 bit at a time using the carry flag to hold any additional carry bit that we may have. And that's all we do, just look it up over here, A, B, and C on the left-hand side, and then set the output down below for the proper column here on the Minecraft board for the proper bit, and then set the carry flag according to the table on the right-hand side. And that's all we do. So I have 2 new binary values on this. You can see I have an A and a B. We're going to add these 2 numbers together using our table. It's very simple. So we start, the carry flag is off. So we have 0, 0, 1 means that our output is a 1, and the carry flag is off. Now, with the carry flag off, and A and B, we have a 1 with the carry flag on. The output is 1, and the carry flag is on. Our next one shows the carry flag on and 0, 0 for A and B. So 1, 0, 0 on our table shows that we get a 1 for output with the carry flag off. Now, no carry flag, so we get a 0, 1, 0, means that we get a 1 for our output. Carry flag is off. Now this is very simple. We have a 0, 0, 0 for our inputs, A, B, C, and the carry flag, which means we end up with an output of 0. And then this one here is 0, 1, 0, which is that we have the carry flag is off. A is on, B is off. Our table says that becomes a 1. And of course, we also have this last thing. It's the same step again. Carry flag is still off, so we output a 1 with the carry flag off. And there you have it. Now, we're going to do a couple more with the base 10 along with it. Okay, so here's our first problem. We have a binary number on the top. If you want to calculate that very quickly in base 10, you're going to add what? 128 plus 64. You have no 32, no 16 plus 8. You have no 4, you have a 2. What do you get? You get 202. That's right, 202. What do you get here? Here, you start with what? You could go backwards, so you could say 1 plus 2 is 3. There is no 4, there is no 8, there is a 16. 16 plus 3 is 19. You can do it either way. So we have, in base 10, 202 plus 19, very simply 220. But let's use our rules to come up with this. Okay, so all we have to do is use our table. In this case, you see the carry is off, that is over here. So we have a 0, 0, 1 for our inputs, this being A and B. 0, 0, 1 means we have an output of 1, and the carry flag remains off. Now we have 0, 1, 1 for the carry. The carry is off, so 0, 1, 1. That means we have an output of 0 with the carry flag. Now, our inputs are 1 for the carry flag, 0, 0 for A and B, which means we have a 1 for output with the carry flag off. We go to the next column. We have carry flag off over here, so 0, 1, 0 for inputs means we get a 1 for the output. Then we move along to this column here, and you can see that we have 0 for the carry flag, 0, 1, which means we have a 1 for the output. And then we move to the next column. We have a 0 for the carry flag, 0, 0, which means this remains 0. We move on to the next one. The carry flag is set off as well. And so we have a carry flag of 0, 1, 0. Our inputs are 0, 1, 0. That means we have an output of 1 with the carry flag off. And we have the same thing again, 0, 1, 0, which means we turn this on. And so then you can see that our answer is 1, 1, 0, 1, 1, 1, 0, 1, which is, if you want to convert that very quickly, 128 plus 64 plus 16 plus 8 plus 4 plus 1, 221. Next problem coming up. So here's our next problem. What is that top number in base 10? Can you figure it out? I'll pause you and let you figure this out. Pause the video and do your own math. What did you get? 141. That's in A. In B, what is this? That's right, 97. 141 plus 97 in base 10. What is this in binary? We follow our simple rules again. Carry flag is off. So we have 0, 1, 1. The output is 0 with the carry flag on. Now we have an input of 1, 0, 0. That is 1 over here, 0, 0. Output is 1. With the carry flag off. Next number, we have a 0 for the carry, 1, 0, means that we have a 1 for an output. The carry flag is off. We do that again, and we end up with the same thing. Carry flag stays off, and we end up with a 1 in the 4th bit. Now, very simple, we have 3 zeros. The carry flag is off, 0, 0. This stays the same as a 0. And what about this position here? In this case, it is 0, 0, 1. We get a 1. We do the same thing here. And then the last one, we get a 0, 1, 0. Table says 1. So there is our output. You want to do the math real quick to see what that is? See what it should be. It should be what? That's right, it is 238. All right, I'm going to indicate one last thing for you and we'll be right back. Okay, our last problem is very simple. We have all bits on and all bits on. So this is going to be very simple because how it goes, our first input is 0, 1, 1. That means we simply turn on the carry flag with an output of 0. Now all of these are going to be exactly the same because I'm going to get a 1, 1, 1, which means we have a 1 for the output. And we leave the carry flag on, so we're going to do that 1, 2, 3, 4, 5, 6 times. And we will do it another time with the carry flag on. So how are we going to do that? Well, this all becomes a 1. So I just simply set all of these on. It's 2 through 6. We're going to pause here. So now we still have the same thing. We have the carry flag on with 1, 1, 1. Our output is 1, and we leave the carry flag on once again. So now this, of course, is 2 to the 7th. This then, you think about this, is 2 to the 8th. That means we now actually have 9 bits. So this number is going to be what? A 9-bit number is 510. That's what we actually end up with in this case. Remember, you can store 512 numbers in 9 bits, and that's 0 through 511. So this is 510. We turn that on, you get your 511. So that is the way it is. Now, if you think about continuing that process that we do, with this carry bit set on, we could do as many of these. I could have another 8 and another 8 and another 8. And as long as I simply go through this process, that's what I do. Well, that is what we're going to do. We're going to build our first adder circuit to be able to add 2 binary numbers together in our next video, which is I38. Hope you enjoyed. If you did, give me a likes, hit that subscribe button to get more. And until then, keep on learning. This is Imroy, out.